What's going on, math people? We're talking about function scatter plots and linear models. So let's jump straight into this. Now, a function itself is a correspondence that assigns to each element of a set exactly one element of a second set, meaning we're going to assign one element of the domain to exactly one element of the range. All right, that will be considered a one-to-one function if none of the ranges repeat. So let's say we have ABC and we have 1, 2, 3. A goes to 1, B goes to 2, and C goes to 3. That is a function. Exactly one element of the domain goes to one element of the range. Another quick example. Let's say I'm just going to write D for domain, R for range. Again, let's say we have ABC, and the only thing we have over here is 5. All of those go to 5. That is still a function because A went to 5, B went to 5, C went to 5. All that is saying is all of these domain values went to the range. The range can repeat all day long and it still be a function. All right, so let's go ahead and keep rolling. All right, the domain. The domain is the set of all first elements of the function or the inputs. All right, I'm trying to give y'all the keys right here. The domain is the set of all first elements of the function or the inputs is called the domain. All right, the variable representing the elements in the domain is called the independent variable. So if we was going to write this as an ordered pair, you would have the independent variable and the dependent variable. Independent variable, dependent variable. So we know ordered pairs on an XY plane would say X and Y. If we translate that, that is saying that the value of Y depends on X. X is independent, does whatever it wants to do. All right, the range is the set of all second elements of the set. All right, and that is the range focuses on the outputs. All right, the range focuses on the outputs. All right, you input an X, you get out a Y. All right, so domain, the first elements of the set, the range, the second elements of the set. All right, let's keep rolling. Let's get into some examples. So a scatter plot. A scatter plot is a graph of ordered pairs, usually like real life data, and like points can just jump anywhere. You just toss them on there. All right. So if we were gonna plot this, the x-axis is the horizontal axis. The p-axis in this particular example is the vertical axis. So x-axis, p-axis. All right. That tells us that p depends on the value of x. So if we go to if x is 0, the p value is negative 100. So you went nowhere on the 0, did not move on the x-axis. If we go to the x-axis of 50, then it says p should be 1050. All right, scatter plots are just points that just appear on the graph, and they might look like random points, but you just keep plotting, keep on plotting. We have 100 on the x-axis, and we go up to 1800 on the graph. All right, and just keep on rolling. 150 to 2050, and 200 on the x-axis. Look at that. That goes to 1800. 250 goes to 1050. So right up here. And 300 goes to negative 200. So we're at 300. Boom. That's a scatter plot. Plotting exactly what you get. This point right here is the point 50, 1050, and so on. All right. Practice doing some scatter plots. Now, right here we have a pretty straightforward example. It wants us to identify the independent and dependent variables. Here's a little secret, right? The independent variable rolls with a lot of company. All right, so whenever you look at your equation or your function, you check out the variable that's rolling with a lot of company. If it has a lot of company around it, that's most likely going to be your independent variable. The dependent variable will usually look like it's solo. So it says, suppose the child's normal temperature is 98.6 and the only thermometer available, which is Celsius, indicates that the child's temperature is 37 degrees Celsius. If the function that relates Fahrenheit and Celsius temperatures is given below as F equal 9/5 Celsius plus 32, Fahrenheit equal 9/5 Celsius plus 32, says what is the independent variable? Just think back right quick. Now, which one of those variables is rolling with a lot of company? If you said C, you're absolutely correct. The independent variable in this equation is C. The independent variable is C. Let me change this color to like blue or something. All right. Independent variable is C. All right. What is the dependent variable? All right. The value of F depends on whatever C is. All right. It says, does this reading indicate that the child's temperature is normal? Like, what in the world is that? That just came out of nowhere, right? Like, so all that is saying is you take that Celsius and plug it into the problem and see what the Fahrenheit comes out to be. All right, so we're going to, Fahrenheit is equal to 9/5 times 37 degrees Celsius plus 32. And we'll get us a quick little answer that'll tell us Fahrenheit. Let's drop that off in a calculator. We have 9/5 times 37 plus 32. Go ahead, change that guy over to a quick little decimal. Give me that in decimal form. 98.6. Right on the money. 98.6. So that tells us that 37 degrees Celsius is equivalent to 98.6 degrees Fahrenheit. So the temperature is normal. Good stuff. Let's keep rolling. The daily profit from the sales of X pounds of candy is shown in the table below. Now remember we said that we have the dependent variable, independent variable. The independent variable always rolls first. So we have independent and dependent. All right, so if you look at this, independent is going to roll into the game first in this set of data. That's your X. That's your independent values. Your P depends on whatever X is. All right? So, and it says the daily profit. So P is for profit and X is for pounds. So 0 pounds, your profit goes in the negative. 50 pounds, you got a profit of $10.50. 100 pounds, a profit of $1,800. And we just keep going from that standpoint. Now, it says, is P a function of X? All right. How do we know if P is a function of X? Let's looking at this, is P a function of X? Yes, it's a function of X. Because every value of the domain corresponds to a single value of the range. All right. 0 does not go to 2 different values or 3 or any. Every last one of these correspond to their own single value. That's it. That is it. All right. So that answer is P a function of x? Yes. Explain your reasoning. Because every value corresponds to its own value. Every value of the domain corresponds to its own value of the range. If it is a function, give the domain and range. The domain would be the x values of the set, and the range would be the p values of the set. The domain would be the pounds, and the range would be the profit. Draw a scatter plot. We'll leave that scatter plot drawing to you all. Just reference the first example where we drew a scatter plot. And if it wanted to work this in reverse, you'll see that P corresponds, if it was turned in the opposite way, then it would be a function of, X would be a function of P. All right, now let's focus on linear functions. Focusing on linear functions, all right, you have y equal ax plus b, where a and b are constants. In this particular case, like you've heard of y equal mx plus b, like that's like the most popular thing, slope intercept form. This is essentially saying the same thing. A is your slope, b is your y-intercept. All right, and this piece here, a is the slope, and b equals the y-intercept. Same thing for the function. This is an equation. This is function notation. I'm going to circle it in a different color. All right, function notation. All right, so let's go ahead and get to work. We stay busy, we stay grinding. All right, the points where a graph crosses or touches the axis, are called intercepts. If it crosses the x-axis, let's draw a quick little layout here. X-axis is your horizontal axis. We have our y-axis. And then let's say we have a little graph. All right. So x-intercepts, where it crosses or touches the x-axis are the x-intercept. Right here we have a touch. So that's an x-intercept. Putting the x-intercepts in red. Over here we have a cross. It crosses the x-axis. All right, so we have two x-intercepts. And then the y-intercept, I'm gonna put that in green. All right, crosses the y-axis here. So we have visuals of what the intercepts look like. All right. One thing you want to keep in mind with the x-intercept, you have some x value, the y value is always 0. With the y-intercepts, the x value is always 0, and you'll have some y value. That x naught and y naught, that's all that is. That's just stating that it's going to be some value. Now, x sub 0, y sub 0 is saying it's going to be some value. All right, so let's keep rolling. Says find the intercepts of the graph of 2x minus 3y. All right, so we have 2x minus 3y equals 12. All right. Now remember, if you finding the x-intercept, I didn't mean to do that. Whenever you find in the x-intercept, what is the value of y? If you said 0, you are on it. All right, so you set y equal to 0. Plug that information into your function. So you have 2x minus 3 times 0, or plug it into your equation. So you have 2x equals 12. Undo the multiplication. We have x-intercept of 6. But we want to write that in as an ordered pair. X value 6, the y value 0. That took care of our x-intercept. To find the y-intercept. We know that the x value is supposed to be 0. So we're going to drop that information off into our function. We have 2x. Moving too fast. Pump your brakes, son. All right, so 2 times 0, because we're finding the y-intercept, minus 3y equals 12. And we have negative 3y equals 12. Undo this multiplication. Y equals negative 4. All right, so we have y equal negative 4. So the y-intercept is 0, negative 4. And it said graph the function. Graphing the function. Draw this quick little Cartesian plane. Go ahead and plot your intercepts. I'm going to plot my x-intercept. I have x value of 6. 1, 2, 3, 4, 5, 6. Boom. And the y-intercept of negative 4. 1, 2, 3, 4. And the graph of the function is the connecting of the dots. You're welcome. All right. So we plotted our x-intercept, we plotted our y-intercept, connected the dots, graphed it. We're in there. Feel free to slow the video down at any time. But let's keep on rolling. All right, so let's go ahead and apply a linear equation to talking about money, right? We always trying to pay off debt. Like, no one likes debt, but here in America, we just stay getting into debt. So we have to figure out ways to pay this stuff off. All right, let's model through this example. We have a business property is purchased with a promise to pay off a $60,000 loan plus the $16,500 in interest on this loan by making 60 monthly payments of $1,275. Amount of money remaining to be paid is $76,500. All right. That $76,500 is reduced by $1,275 each month. Although the amount of money remaining to be paid changes every month, it can be modeled by the linear equation below. All right, you might be asking yourself, where did $76,500 come from? That's $76,500. The loan, $60,000. The interest on the loan, $16,500. Add those together, get you your $76,500. So that's how much debt we're in right now. All right. So we're modeling this. We're building this thing. All right. So we have Y. It said Y is the money remaining to be paid. So Y equals the $76,500. And if you are paying money, it said here it's reduced by $1,275. So reduction, that's a minus sign. $1,275 each month. So you got to put a variable on that $1,275, and that's the building of your equation. All right, we're going to continue using this equation. It says find the x-intercept and the y-intercept of the graph of this linear equation. So we have y equals 76,500 minus 1275 x. For find this equation, the y-intercept is easy. Like, the y-intercept is easy. It's the easiest. I'll say it like that. The x-intercept takes just a tad bit more work, but we got this. We math people. So we have find the x-intercept. That tells us to set y equal to 0. So we know y equal to 0. So when we plug that into our equation there, we have 0 equals 76,500 minus 1275 x. And then we'll solve for x. All right. Subtract that 76,500 to each side. 76,500 negative 76,500 equal negative 1275x. Undo the multiplication. Undoing the multiplication, we have negative 76,500 divided by negative 1275 equal x, and that gives us the x-intercept is equal to 60. What does that tell us? X-intercept is 60, so that's after 60 months. The amount owed is 0. All right. Finding the y-intercept. Finding the y-intercept. To find the y-intercept, we let x equal 0. So we have y equal 76,500 minus 1275 times 0. Y equals 76,500. What does that mean? That means if you make no payments, your balance is still 76,500. All right. So interpret the intercepts in the context of the problem. I was speaking too fast. That's what we were doing in the interpretation whenever I was speaking. All right. The x-intercept. X-intercept tells us of 6 to 0 as a balance of 0. $0 after 60 payments. And the y-intercept says no payments, 0 payments, means balance of $76,500. How should X and Y be limited in this model so that they make sense in the application? Well, for certain, X cannot be negative, right? Because you ain't gonna make a negative amount of payments. All right? And your Y, it needs to be capped at 76,500. All right, it wants us to graph it. Graphing, all right, we have, let's say that this is 60, and way up here is way up there. That's a Y value of 76,500. And when we graph the function, connecting those two dots, that's supposed to be a straight line. Forgive me. All right. you can see that your balance should be decreasing the more payments you make. All right, let's keep rolling. The slope. Slope is the vertical change over the horizontal change. All right, slope is the vertical change over the horizontal change. Or better yet, slope is the change in the y-axis over the change in the x-axis. Some people use the memorization trick of rise over run. All right, so there are 4 types of slope. You have the positive slope, and that's when the graph is rising from left to right. You have a negative slope when the graph falls from left to right. You have the zero slope when you have a horizontal line. And you have the undefined slope when you have a vertical line. All right. The formula that's used for the slope is lowercase m equals the change in the y values over the change in the x values. All right, if you have points, this is the formula that you'll use to determine the slope. Right, let's go ahead and grab that guy. We already went through this. All right, find the slope of the line passing through the point. So we'll toss our formula up here since we're just introducing it. y2 minus y1 over x2 minus x1. All right. Doesn't matter which point you choose to be y2. Which point to be point 1 and point 2. It doesn't matter as long as you're consistent. So you have m equals 2 minus negative 4 over negative 3 minus 5. That gives us 6 over negative 8 equals negative 3/4. What does the slope mean? For every for every 4 changes in x, y changes by negative 3. Slope and y-intercept. The slope of the graph of the equation y equals mx plus b, and the y-intercept of the graph is b. All right. M, we already talked about this earlier. This is the slope. If we're focusing on slope-intercept form. B is the y-intercept. We got this though. Let's keep digging. Determine the slope and y-intercept. All right, first thing you do, identify the variable. The slope is always the number attached to your variable in a linear equation. So your slope is equal to 7. The y-intercept is the constant that's standing alone. The constant that stands alone is negative 12. Too easy. Whenever it's in slope-intercept form, you just look at it. Y equal mx plus b. Easily identify the slope. But whenever it's in general form, you have to rewrite your problem and then get to work. Rewrite your problem in slope-intercept form. So Slope-intercept form, I'm going to move the x to the opposite side of the equal sign. Divide each side by the -3. All terms. And we have y equals 2/3 x minus 4. Now, what is the slope? M equals 2/3. What is the y-intercept? The constant, b equals -4. All right, let's keep on rolling. All right, looking at this example that we did earlier, all right, it wants us to look at this and identify the slope and y-intercept from that example. All right, identify the constant. The constant is the one that's not attached to a variable. It's the one that rides alone. So your y-intercept is 76,500. The slope is the value attached to your variable, -1,275. How does the amount owed on the loan change as the number of months increases? The more payments you make, the lower your balance is. Like when we saw before, like this slope tells you, if we was just to use what we know about a slope, if the slope is negative, the graph falls from left to right. And so that tells us that that balance of 76,500 is going down until we get to 0. And that happened at 60 months. At 60 months, we had a 0 balance. At 0 payments, we had the $76,500 balance. Constant rate of change is another way of calling out slope of a function, and it describes how much the output changes for every input unit. All right, so what is the slope of the graph of this function? The slope we easily identify. We do not include x. Now, the slope is just a value that's attached to your variable. What does this slope tell us about the annual rate of change in the percent of Hispanics in the U.S.? That slope, since it's positive, it says the percent of Hispanics in the U.S. is increasing by 0.224. And per year. All right, we're talking about the equation of a line still. We've gone through slope-intercept form. Let's keep rolling. We're going to build this example using into slope-intercept form. An appliance repairman charges $60 for a service call plus $25 per hour. Assuming his service call charges can be modeled by a linear function of the number, write the equation below. So we'll let y equals the balance for the employee, the repairman service. He said he gonna charge you $60 just for showing up. All right, $60 just for showing up plus $25 for every hour he has to be there. And so he want all his, or she want all hers. Either way, whoever it is want that money. All right, so we built the equation. Point slope. Point slope is the equation of a line with slope m and passing through a known point. This particular version for the equation of a line will be used often throughout algebra, calculus. It will be used often. All right. So it says write the equation of a line through the point 3, -7, having slope -2. All right, I want the equation of a line. So I'm going to bring in point slope. Y minus y1 equals m times x minus x1. And just plug in the values. All right, anywhere you see a subscript, that gets a value from your point. All right, now we have y. The y value from the given point is -7 equals the slope given is -2 times x. The x value of x1 is 3. Boom, bada bing, bada boom. You have y plus 7 equals -2 x plus 6. But don't leave it like that. Get your final answer in slope intercept form. Oh, I didn't mean to put -7. That should be -1. Where did that -1 come from? By deducting 7 from each side. All right. You'll use it often. Let's keep rolling. All right, suppose you're given only 2 points and it says find the equation of a line. Still no biggie. You know how to find the slope. Slope formula. You use the slope formula, changing the y values over the change in the x values. You use that to find your slope. So I'm going to go ahead and find my slope. I have m equals changing the y values from I minus 4 over the change in the x values, -1 minus 2. Again, you just make sure you know which point you choose to be point 1 and point 2. For me, this was point 2. This was point 1. We have 1 over -3. So we have our slope, and then we use point slope to find the equation of the line. All right. Y minus y1 equals m times x minus x1. Come on with it. Y minus y1 minus 4 equals m. We just found m times x minus the x value that was associated with that y. So we have y minus 4 equals -1/3 x plus 2/3. But again, write that final answer in slope intercept form. Y equals -1/3 x plus 2/3 plus 4. Final answer is y equals -1/3 x plus 14/3. And then finally, last example. It says the number of people in prisons or jails in the U.S. grew at a constant rate from 2001 to 2013, with 1.345 million people incarcerated in 2001 and 1.57 million people incarcerated in 2013. What is the rate of growth of people incarcerated from 2001 to 2013? So we use the slope form to find that rate of growth. You got 225,000 people in jail over the 12-year span. The change in the y over the change in the x, the number of people in jail depending on the year. So we calculated that to be 18,750. And then It says write the linear equation that's associated with that for the number of prisoners. All right. It says n of prisoners as a function of x year. All right. It gave us the variables that it wants us to use. N is for your dependent variable. The number of prisoners depends on the year that we're talking about. And then it wants us to predict it. All right, I left us a blank screen over here. All right, so we have n prisoners is equal to m times x plus b. Well, not so much plus b, but didn't even mean to write that. We're supposed to be doing point slope. So we have n minus n1 is equal to the slope times x minus x1. Don't let the change in the variable mess you up. All right, so we already found the slope, and the year that I chose was year 2013. All right, so just look right up here, year 2013. All right, so my x value is 2013. There was 1.57 million people in prison in 2013. So we're just gonna plug this info in. All right, it ain't gonna be no biggie. N minus, what's the y value? N stands for people, so I'm gonna go ahead and put in 1,570,000 equal to that slope of 18,750 times x minus, we're talking about 2013. We'll put all that into calculation. N equals 18,750 x minus, oh, your boy brain ain't doing that. Let me grab a calculator. 18,750 times 2013. Whew. 3 million. Hold on, 37 million. Hold up. 37,743,750. 37,743,750 plus 1,570,000. All right, where'd that come from? We had to add this guy to both sides because we want our final answer in the slope-intercept form. All right, let me go ahead and add that to this. Plus 1 million. Hold up. Cause that's negative, right? Plus 1,570,000. So that's 36,173,000. Oh Lord, equals 36,173,750 people. And then it says in year 2017, how many people can we predict? You would plug in x equal to 27. So we found our equation. So we have 18,750 times 2017 minus 36,173750. That would tell us in 2017 we have 1,645,000 1,645,000 people in jail. Painful. All right. Hey, that's a wrap. You all feel free to holler at me. My math people,